Hello, everyone. We are back again to our math journey, and I hope each and every one of you is doing great. If you haven't subscribed to our channel, kindly subscribe to our channel, Tutoring Made Easy, and like this video and share it to as many people as possible. We also welcome any comment and suggestions. So feel free to drop your comments in the comment section below. If you have a specific topic you want us to discuss on a video, feel free and share it in the comment section below. But today we are going to continue from where we ended. We started with logarithms and we are still ongoing. We mentioned that logarithm was propounded by John Napier in 1614. We also said that logarithm is of the form, it takes the form log b to the base a. And we said that this is usually called the base. Yeah, it's usually called the base. And if it is equal to x, the result, this is usually called the exponent. The exponent or power. We mentioned this. And then we went straight into the first law. We said the first law says that if you have log of 1, it's 0. We already proved that. We looked at that and we said that to prove that, we set the log 1 to x. So that we said that if you write a log without a base, it's just in the base 10. It's assumed you're in base 10. So that means 10 to the power of x. Why x? Because we said this is usually the exponent is equal to 1. And we write the 1 also in the form of 10 to the power of 0. Why? Because we have a base that is 10 here. And since this base is the same as that base, then x is also 0. So that's the proof for the first law. Now let's look at the second law. The second law says that if you have log of AB is the same as log A. It says if you have log of AB is the same as log A plus log B. Log A plus log B. Now, if we want to prove it, what we can do is that this one here, we can write this one as log A is equal to x. Now, since we are in base 10, that's going to give us 10 to the power of x is equal to a, right? Because this is the exponent. So it comes here. And then this is the base. And then this is the result. Now, the next thing there is that we can also rewrite this one as log b is equal to y. And then we are working in base 10. So 10, which is the base, exponent y is the b. Is the b. Is the b. Now, this is equation 1. Let's imagine this is equation 1, this is equation 2. And we say let's multiply. If we say that we should multiply equation 1 by 2, what it will mean is that we have 10 to the power x, which is a, multiplying, we're going to multiply it by 10 to the power of y, which is b. So what do you think we're going to get? We're going to get 10 to the power of x multiplying 10 to the power of y is equal to a times b. It's equal to a times b. And we know clearly that because this base and this base are the same and the multiplication sign is in the middle, we are going to add the exponents. We're going to have 10 to the power of x plus y is equal to ab. Now, I hope we see the drift where we are going with this. Now, we are having ab is equal to 10 to the power x plus y. Now, when we take log of both sides, take logarithm of both sides, we're going to get log of AB, because take log of this, log of AB. It's equal to log of what? 10 to the power of x plus y. To the power of x plus y. To the power of what? X plus y. To the power of x plus y. So we're going to have, we're going to have log 10 to the power x times, right? No, we're gonna drop, sorry, we're gonna drop, okay, we're gonna drop this thing at the back of it. The x plus y, we're gonna drop at the back. And then we are going to have log 10. And then we have log of AB here. Now we're going to learn from another law that because this is log 10 to the log 10 to the base 10 is equal to 1, we're going to have log of AB being equal to x plus y. And we know that this x is log A, and we know this y is log B, and we are adding them together. All right. So this is how we prove log of AB to be equal to log A plus log B. Please kindly pause the video, go back and front, and I think if there's anything that is bothering you or it's not clear, as you go back a little bit and then you pause the video, everything will become very, very clear. Now we're going to look at the third law, right? We're going to look at the third law, and I think it's similar to what we just did. The third law says that if you have log of A divided by B is the same as log A minus log B. Now, what we can do is that we can drop this and say this log A is supposed to be X, so that we have 10 to the power of X, because this exponent is equal to A. And then also, this one can be log of B is Y, where you have 10 to the power of Y is equal to B. Now, we know that we can multiply these two. We can multiply these two. So we have 10 to the power of x, which is A, multiplied by 10 to the power of y, which is B. And when we do that, we're going to get 10 to the power of x plus y, because you're multiplying this base and this base, they are the same. So when you multiply, we add the exponent, and it's the same as A times B. A times B. So now we have we can take logarithm of both sides. So they have log of 10 to the power x plus y is equal to log of AB. This one is the log of AB. Now, one of the rules says that we should drop the x plus y at the back. Because of this, we drop it at the back and we have log 10, which is equal to log AB. Now, because this log 10 is 1, we have x plus y multiplying 1, which is x plus y, is equal to log of AB. Okay, now we're going to bring it here. Remember that the x is equal to log A, don't forget, and then the y is log B. So we're going to have x plus y, which is log of AB. We're going to plug the x there, which is log A. Log A plus log B, and we get log of A B. So this is the proof for the multiplication, the second law. But with the third law, what we do is that instead of multiplying, we divide. So I'm going to come back, instead of multiplying like here, over here, instead of multiplying, we divide it. We divide it. We divide it. And when we divide, we're going to get here to change. We're going to change here. Here is going to be x minus y. Because if the bases are the same and you're dividing, we normally subtract the top. And we get it. If you take log of both sides, this one here, the x plus y is going to be x minus y. So here is also going to be x. Sorry about the confusion. Here is also going to be x minus y, like this. And then this is also going to be x minus y. Okay, x minus y. So this is gonna be x minus y. You go to log of a divided by b, right? Log of a divided by b. Log of a divided by b. Log of a divided by b. Sorry for the confusion. So yeah, so now we're going to have a divided by b. Now the x there is log a, and then minus the y is log b, which is log of a divided by b. So they are similar. The difference between the second law and the third law is that operation sign, multiplication, and division, respectively. Now we have been able to prove first law, second law, third law. Now I don't know whether we did the fourth one. The fourth one was to drop the exponent or the power of the logarithm to the back of the logarithm. So I'll try and remind you a little bit. Maybe we have forgotten. So maybe you have log of a to the power of n. We said it's the same as dropping the n at the back of the log and have something like this. So if you have, let's say, log x to the power of 2 is going to be 2. We drop the 2 at the back and we have log x. That's what we agreed on. Now, the fifth law, we're going to look at the fifth law. If you have, let's say, log of, log of a to the base a, we said it's equal to 1. If the result is the same as the base, then the answer is going to be 1. If this thing here is the same as the base, it's always going to be 1. So let's take an example. Let's say you have a log of 1,000 to the base 1,000 is always going to be 1. If you have a log of 10, then log of 20 to the base 20 is equal to 1. Now, how do we prove that? Now, we have log of a to the base a. We equate it to x. Now, because this is our base, we write the base and we take the exponent, which is x, is equal to a. Now, you see that this base and that base, they are the same. And there's an equal to sign in the middle. That means that the exponents are also equal. So x is equal to 1 because this is the same as a to the power of 1. So x is equal to 1. 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 So that's the fifth law. The fifth law. I think we should do the last one and then we end. I'm going to take us through the change of base. Let's say you have a certain base in a log and you want to change it to another base. Okay, I think we'll end here. I'll do that in a separate video. All right. Thank you for spending time with us. So if you haven't subscribed, please do us a favor by subscribing, liking this video, and sharing it to as many people as possible. We also welcome comments and suggestions. If you have a specific topic you want us to do a video on, please feel free and put it in the comment section below. All right, so I'll come to you another time. Take care and bye.